Hi, I'm going to solve this problem for you, projectile motion, where we have a ball being thrown off the top of a building. It's not thrown horizontally, it's not thrown straight up, it's thrown at an angle with respect to the horizontal, 30 degrees above the horizontal with a speed of 20 meters per second, and the building is 45 meters high. So the question is asking how long does it take for the stone to reach the ground, and then what is the speed of the stone just before it strikes the ground? This is a good one. All right, so we're going to follow our problem-solving strategy here. Here we go. All right, so our first step is to draw a picture. So I have the side of the building, like that. I have stone launched up at an angle. This is not something you really should do, by the way. That's 30 degrees. The initial velocity is, what was it, 20 meters per second? Yes, 20 meters per second. Okay, the building is 45 meters high. Okay, and we want to find the time to hit the ground and then V final. It asks for speed. Yes, so not the, we don't need the direction, but just the speed. Okay. All right, so it's a two-dimensional problem. It's a vector problem anyway, so we need to set up our coordinate axes. So I'm going to put it down at the bottom of the cliff. That's my origin, and I'm going to say my positive x axis is in that direction, and my positive y is up. So again, standard coordinate axis. Once the ball is thrown and leaves somebody's hand, it's just moving under the influence of gravity, right? Acceleration is just due to gravity. Okay, so let's make our list of what we're given. So I'm going to organize all my x's together: x0, x final, v0, x, and ax. Okay, I'm going to make my box. x0, initial x position is going to be 0. The ball's going to go up. Sorry, it's going down to my given here. I'm going to drop over there, so x final, we don't know. V0x, we'll talk about in a second. Ax is 0. Okay, so for y, we have our initial y position. Since I put my origin at the bottom, my initial y is going to be up at 45 meters. My final y is when the ball is just about to hit the ground, so final y is 0. V0y we'll look at in a sec, and ay is going to be minus 9.8 meters per second squared. Okay, so we're also given that theta equals 30 degrees. All right, so when you have this situation with an initial velocity at an angle, we need to break it into its horizontal and vertical components. That's theta. Okay, so until you get totally comfortable with this, just go through your trig definition. So here's theta. So my sine is the opposite over the hypotenuse. So sine theta is my opposite side, so that's v0y over v0. I solve for v0y to get v0y is v0 sine theta. And then I can get the x component using cosine. So cosine of theta is my adjacent side over the hypotenuse. So v0x over v0. And again, I want to solve for that. So I get v0x equals v0 cos theta. Okay, so that's what we know for v0x is v0 cos theta and v0 sine theta. V0 we know is 20 meters per second. And then we have the sine of 30 degrees. So sine of 30 is a half, so this is 10 meters per second in the y direction. Okay, and then for the x direction, it's 20 meters per second times cosine of 30 degrees. And if we calculate that out, it is 17.3 meters per second. Okay, so we could either put those values up in there or just leave it like that. Okay, so first thing we need to do is find time, and it's always the y equation that determines the time of flight. So I don't want anyone to be afraid, but this is going to involve a quadratic equation. So y equation of motion gives time of flight. So our y equation is y final equals y initial plus v0 yt, initial y velocity times time, plus 1/2 ay t squared. Okay, so we're going to cross out anything that we know is 0, which in this case is only y final. So we get 0 equals y0 plus v0 yt plus 1/2 ay t squared. Okay, now don't panic. You guys know the quadratic equation, right? So in general, we have, if you haven't seen it in terms of solving for t, but you know that for a quadratic, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what's a, b, and c? A is the coefficient of the t squared term. This is a. Okay, b is the coefficient of t, and c is the constant. Okay, so we can rewrite that in terms of the variables in our equation of motion. So negative b is negative v0y plus or minus the square root of b squared. So v0y squared minus 4a. So don't confuse that with acceleration. That's a in terms of the term in front of t squared, which happens to be 1/2 times the acceleration in the y direction, and then times c, which is y0, all over 2 times a. So 2 times 1/2 ay. Okay, we can just simplify that a little bit. It's negative v0y plus or minus the square root of v0y squared. I get the 4 divided by 2, so it's minus 2 ay y0. And then on the bottom, I get 2 times 1/2 times ay, so that's just ay. So that's t. So I'm actually going to get two roots, right? So we're going to solve for one time using the plus and one time using the minus. So let's plug in our values here. So we have negative v0y is 10 meters per second, plus or minus the square root of 10 meters per second squared, minus 2. Acceleration is negative 9.8 meters per second squared. Okay, and then y0 is 45 meters. And then divide by ay, minus 9.8 meters per second squared. All right, so I did this math out before, just so we have the values, and we get two values of t. We get negative 2.18 seconds and 4.23 seconds. And this is the one that we want. So what we're really doing, right, if we look at this problem, here's our building. So we're looking at the projectile moving up with some velocity, right? It's going to go up, and then it's going to come back. I'm trying to make that a little smaller. It's going to go up and come back down and hit the ground over here, right? But what we've actually asked when we solve for time is just to tell us when does this y position, this is really y as a function of time, right? When is that value going to be 0? So forward 4 seconds, it looks like that. If we actually go back 2 seconds, we trace out the other side of the parabola and find where it hits over here. So this is just a math equation, right? It doesn't know that this negative time doesn't make sense, but it's going to tell us for this parabola where are the two places that it would intersect with 0. Okay, so we just want to ignore that negative time. Not ignore it, it's nice to know what it means mathematically, but it's not the physical solution we're looking for. Okay, so then our final y, let's see if I can squeeze it in here, even though it's not what you should do. So v final x is v0x plus acceleration x times time. Acceleration is 0, so that goes away. So v final x is just v initial x, which we said was 17 meters per second. Okay, so that's part of our answer. And then we have v final y is v initial y plus ay t. So now it's 10 meters per second minus 9.8 meters per second squared times 4.23 seconds. Okay, this one I didn't calculate ahead. So let's open up a little my Python window here. So we have 10 meters per second minus 9.8 meters per second squared times 4.23. So we get v final y is negative 31.5 meters per second. Okay, we'll go back to this. And, oh boy. Hold on. Okay, so now let's combine these velocities. So we'll go on to the next page. So v final x is 17. 17.3, and v final y is negative 31.5. So it means it's going down. It's almost twice as long. V final y is 31.5 negative, right? So it means that it's pointing down. So when we want to find the final velocity, we have to take the magnitude of those two velocities, right? So it's going to be from the start of the Vx to the end of Vy. So V final is going to be equal to, by Pythagorean theorem, V final x squared plus V final y squared. Okay, so square root of 17.3 meters per second squared plus negative 31.5 meters per second squared. So let me check Python. Square root of 17. I should actually do NP, that's square root, so I don't confuse you guys. NP square root of 17.3 squared plus negative 31.5. I mean, I know that's going to go away, but just to be technically correct, the negative sign will go away. And I get 35.9. Meters per second. Okay, so that's all I was asking for. But what if it also asked for a direction? So meaning that we'd want to solve for some angle like theta here. So let's just go through that so we have an example of that too. So if we want to find theta, so we would use our tan function. So tangent is opposite over adjacent. So tan theta is my opposite sign. So v final y over v final x. Okay, if I want to get theta by itself, to solve for that, I have to do the inverse tan of both sides. So the inverse tan of theta is just theta. And then I have to do inverse tan here too. Theta equals inverse tan of v final y. So 31.5. I'm not going to worry about the direction yet. That's meters per second. And then 17.3 meters per second. Okay, now I go back to my Python window. P.arctan 31.5 divided by 17.3. That's going to give me an angle in radians, and I want to convert that to degrees. Okay, so theta equals 61.2 degrees. Now I could say that is, remember all of our angles are measured relative to the plus x-axis, right, which is in this direction. So I could say that is minus 61.2 degrees below the x-axis, or I could go around counterclockwise. I could say that it is 360 minus 61.2 degrees. I could also say that theta is 298.8 degrees, and that's counterclockwise from plus x. So that would be saying going all the way around this way. Okay, and let's call that one done.